This video is on graphing quadratic functions. Let's start off by defining the type of quadratic functions we'll be looking at. So quadratic functions have the form, or can be written in the form, f of x equals ax squared plus bx plus c, where a, b, and c are real numbers and a doesn't equal 0. So when I look at this function, a, b, and c will be real numbers. A doesn't equal 0 because if it equaled 0, this first term would just be 0 and cancel out. And to be a quadratic function, we need that highest power to be 2, right? So that's why we need a to be not 0. So they're real number coefficients. The x's, remember, stay x's because they're functions of x. Generally speaking, these are parabolas when you graph them. And you've probably seen parabolas before. They usually are a U-type shape, either opening upward or downward, depending on the properties. So they look kind of like that. We'll talk more about them specifically in a second. The graph of f of x equals ax squared plus bx plus c can be obtained by using the following properties. So, first one we'll look at. We're looking at a, the leading coefficient. If a is greater than 0, then our graph opens upward. Think of it as being able to be like a bowl shape, right? Opening upward like that. Holds water. If a is less than 0, it opens downward. So the parabola would be upside down. So that's just based on the sign of a, right? If a is positive, that's what greater than 0 means. It opens upward. If a is negative, right, less than 0, opens downward. Second thing we look for when we have a parabola in this form is the axis of symmetry. The axis of symmetry is an imaginary line that splits the parabola in half right down the middle. So the axis of symmetry is given by x equals. It's a vertical line, meaning it goes straight up and down. And there's a formula for it. It's negative b over 2a. So remember our a, b, and c from our function here. So negative b over 2 times a, and that'll give you the equation of the axis of symmetry. Make sure you have the x equals in there. It's an equation. So that'll be the imaginary line that splits the parabola right in half. The third thing we look for is the vertex. When I say the vertex, we're really talking about the highest or lowest point. Of the parabola. It's based on if it opens upward or not. So if it opens upward, the vertex is the bottom, right? It's the lowest point. If it opens downward, it'll be the highest point. So the vertex is either the highest or lowest point and is given by the coordinates. And the coordinates come from, the axis of symmetry is the x value because it has to split it right in half for the axis of symmetry, so it goes through that vertex. Either that, the bottom of the U or the top of the U. So the x value in the ordered pair would just be the negative b over 2a. the y value that goes along with it. Well, how do you find the y value for a function? Well, you would sub x into the original function f of x to get the y value out. Now this is going to be a number, so it's really going to be f of whatever that number is. In this case, generally speaking, it's f of negative b over 2a. I wouldn't memorize this part. I would just understand that whatever I found for the x value of the axis of symmetry is what I substitute in to find the y value for the vertex. And then the last things that we look for is we find the x-intercepts. And that's if they exist. There doesn't have to be an x-intercept. The parabola could be either completely above or below the axis, but the x-intercepts, if they exist, and the way you do that, you set y equal to 0, because to be an x-intercept, it has to be on the y, or it has to be on the x-axis, so the y value is 0, right? So for x-intercepts, the y value is always 0. And the y-intercept which will always exist, and you find that by setting x equals 0, because to be on the y-axis, the x value is 0. And the last thing you do once you have all that is graph. All right, so we'll look at a couple of examples using this. These are for the parabolas that have, this form of ax squared plus bx plus c. If you have something that's has a function with the highest power of 2, there'll always be a parabola. If it's not in this form, you could always get it into this form to graph it. So let's take a look at an example here. So if I said in this example to graph f of x equals x squared plus 6x plus 8. First thing to notice, right, before we go through this is that our function is a parabola because the highest power is 2. So you know it's a parabola based on that. And once we're there and we know it's a parabola, we should look for those things that we just talked about on the previous page. So the first thing I'm looking for is, how's it open? And that's based off of, remember, the leading coefficient, the number in front of the x squared. Is that positive or negative? Well, in this case, it's a positive 1. So it opens, the answer here is upward. Right? In other words, you know it's going to look like that. You know this because a is greater than 0. Right? In other words, a equals 1. It's positive. So it opens upward. And that's good. So we know something about the shape of our graph right away. Second thing we're going to look for is the axis of symmetry. Remember, for the axis of symmetry, we have a specific formula we use. We use x equals, right, because the vertical line is going to split the parabola in half. X equals, remember, it's negative b over 2a. And we want to substitute into this formula. So negative b is negative whatever b is. B in this case is 6, so it's negative 6 over 2 times a. It's 2 times the leading coefficient, so it's 2 times 1. So we end up with negative 6 over 2, which equals negative 3. So the axis of symmetry is given by x equals negative 3. You need the x equals because it's an equation of a line. Remember, x equals a constant is a line that goes straight up and down. Right? It's a vertical line through that value on the x-axis. So this is the imaginary line that's going to split our parabola in half. If we're looking at our graph, you already know then, right, and I can maybe bring this up here so you can see it, right? If I'm looking at this graph and I want x to be equal to negative 3, so negative 1, negative 2, negative 3 is the x value, assuming these are all 1 apart, you're going to have this imaginary dotted line that is the axis of symmetry. It's splitting our graph in half, in other words, the graph of the parabola we're about to get. We'll look more at that in a second. Step 3, we said find the vertex. To find the vertex, all right, so we're looking for the vertex. The vertex, remember, is the highest or lowest point. Since we know this parabola opens upward, it's going to be the lowest point on this parabola, the bottom of where the U is. So the lowest part of this parabola has an ordered pair. The ordered pair, the x value has to be -3. We know that because of the fact that the axis of symmetry goes right through the middle, and that's where that lowest point's going to be. So I need to get the y value that goes with that. To get the y value, we just take f of -3, right? We're summing in x to get y out. So we have f of x up here, which was equal to the x squared plus 6x plus 8. So f of -3 is going to be -3 quantity squared. Make sure you have parentheses around that. Plus 6 times -3 plus 8. And we're going to evaluate this. -3, the quantity squared is 9. A positive 6 times -3 is -18 plus 8. And then adding these together, 9 minus 18 would give you a -9 plus 8 gives you a -1. So the vertex, right, has an ordered pair, right? So here's my vertex. We just found it is an ordered pair. The x value is what you subbed in, the -3. The y value is what you got out, the -1. So I know this point, -3, -1, is going to be on my graph. So if I bring my grid back over here, the point -3, -1, the x value is -3, the y value is -1. I know that point there will be on my graph, -3, -1. And I know it's my vertex. Maybe I'll label it with a V for vertex, just so you know what it is. You could label it with the coordinates as well if you wanted. But the other thing to notice is that now I know this graph opens which way? It opens upward, right? We talked about it up here. If I know this opens upward, then I can tell from my vertex right away. If I was opening upward from there, I'm going to cross the x-axis, so I know my x-intercepts exist. We'll talk about finding them now, but you always want to look at that pretty early on to make sure you're not wasting time trying to find something that doesn't exist. And we'll see an example with that in a little bit. So step 4 here, we're going to look for the intercepts. Right, the intercepts, we're talking about the x-intercepts and the y-intercepts. So for the x-intercept, remember how you're supposed to find these. You set y equal to 0. If I set y equal to 0, that's like setting the f of x side of my function, right? F of x and y are interchangeable. So it's really saying 0 equals x squared plus 6x plus 8. And you want to solve this. To solve this, you should always try to factor first. You know, you could always use quadratic equation later on for the quadratic formula, but this factors 2 sets of parentheses, x and x, multiplies 8 and adds a 6, so it's x plus 4, x plus 2. And then you want to set each of those factors equal to 0, right? So we say x plus 4 equals 0, x plus 2 equals 0. Solving each of these, you should know how to solve these. We'll subtract 4 from each side. We get x equals -4. Subtract 2, I get x equals -2. So those are the x values for my x-intercepts. If I wanted to write these in ordered pairs, which typically you'll be asked for them that way, the point is -4, 0, and the other x-intercept is at -2, 0. Now, when you find intercepts like this, you could get one intercept that repeats itself, you could get 2 like I did here, or you could get none. It really depends on the shape of the parabola and where it's located. For the y-intercept, we want to set x equals 0. You always set the opposite coordinate equal to 0. So when I take my f of x, right, my f of x is equal to x squared plus 6x plus 8, I'll use y instead of f of x, so we'll have y equals x squared would be 0 squared plus, when I say 6x, it'd be 6 times 0 plus 8. This ends up being y equals 8. So as an ordered pair, the x value is 0, the y value is 8. And you might have noticed it right away, because if you sub 0 into here, you're just going to be left with the constant at the end. If you see that immediately, you could just find the y-intercept. You don't actually have to show the work for that. I just wanted to make sure you understand where I got it from. So now I'm ready to plot the rest of this this parabola. So I've already plotted my vertex, right? There it is right there. I'm going to plot these other points I know. So we're plotting -4, 0, and -2, 0. Well, -4, 0 is -1, 2, 3, -4, 0 will be there. -2, 0, 1, 2, 3, -2, 0 should be there. And it should be symmetric over your axis of symmetry. That's why we have the axis of symmetry. And for the y-intercept, 0, 8, so 0, 1, 2, 3, 4, 5, 6, 7, 8, right? 8 on the y-axis, that gives us another point. Now we could draw our curve in right now. What I would recommend is use your axis of symmetry to help you get an additional point, a fifth point here, right? If I am 1, 2, 3 units away from the axis this way, I should be 1, 2, 3 units away from the axis of symmetry that way. And that helps me keep my parabola symmetric. Remember, this is a curve, so it should, you know, curve up and through. Arrows on the ends, because this does go on forever in both directions. You may have learned to do this just by plotting points in the past. You want to make sure that you understand how to graph using this equation. And then we can label our parabola f of x equals x squared plus 6x plus 8. So, you know, we use the properties to help us graph that parabola. Remember, it's a smooth curve. It doesn't come to a point. But having to understand how to graph parabolas is an important topic throughout math. Let's take a look at one more example here. So let's do this one here. If I said, for example, we're going to graph f of x equals negative 3x squared plus 6x minus 4. All right, so first thing you should notice, it is a parabola, right? The highest power you see is 2, which is good. And then we're going to ask ourselves the questions we just talked about. So first thing, which way does it open? Now, if I'm looking to see how it opens, we're basing it off of the leading coefficient. We're basing it off of a. And in this case, you know, a is negative, right? So a is less than 0, which tells you it opens downward. In other words, parabola will be upside down, right? So it's going to look like that at the end of the problem. So we know it opens downward because a is less than 0, right? A is negative 3, right? Just so you see it, a equals negative 3. And then the next thing we look at is the axis of symmetry. To find the axis of symmetry, you're using our formula x equals, remember you need the x equals, don't leave that out, negative b over 2a. Well, negative b would be negative, in this case, 6. And if this was a negative in here, you'd have to take a negative of a negative, right? So be careful, right? So it's negative 6 over 2 times a. So 2 times a in this case is negative 3. So end up with negative 6 over negative 6, which equals a negative divided by negative makes it a positive. So it's a positive 1. So the equation for the axis of symmetry is x equals positive 1. And you probably want to sketch this as you go along. So if I'm looking at my graph here for x equals 1, remember that's a vertical line straight through 1. So here's my axis of symmetry. And this is x equals 1. It's a dotted line because it's really an imaginary line that cuts the parabola in half. It's not necessarily part of the parabola, so you don't want to use it as part of the graph. That's why we keep it as a dashed line. All right, the third thing we're going to look at here is the vertex. Remember, to find the vertex, what you're going to do is you substitute in your x value from your axis of symmetry into your function to get the corresponding y value. So we're looking for f of 1, which means we have this equal to, this is negative 3 times 1 squared plus 6 times 1 minus 4, just substituting in. And that gives us negative 3 times 1 squared is just times 1. So it's just negative 3 plus 6 times 1 is just plus 6 minus 4. So we know that this equals negative 3 plus 6 is a positive 3 minus 4 gives us a negative 1. So the vertex, remember, it's an ordered pair. It's x comma y. My vertex actually has the coordinates 1, negative 1, x comma y. So we should plot that. So if I'm going to plot on my graph the vertex of 1, negative 1, it should be on the axis of symmetry for sure. 1 is the x value, negative 1 is the y value, so that our point is right there. I'll label it with a V for vertex just so you can see it. And then once you have that, what you really need to do is think to yourself, all right, I got to find the intercepts now. Now, if we know this parabola opens downward, right, we talked about it up here. If I know this opens downward and this is my vertex, that means the vertex is at the top of it. So if I was to draw this in as a little sketch here, Well, that's the top. Tell me about the x-intercepts. Well, it never makes it to the x-axis, right? So there are no x-intercepts. So typically, to find the x-intercepts, you would want to set your function equal to 0. But if you did it in this case, you're going to get non-real answers, which is okay. But I have an understanding that if you don't get real answers, then it doesn't cross the axis there. So intercepts. For the x-intercept, typically we set y equal to 0. But in this case, for the reasons I just mentioned, the answer here is there are none. And that's okay that there are none. You know, we looked at the graph. And it's opening downward from the vertex. That's a little note for ourselves, just so we remember how we did this. If you did set this equal to 0, right? If you set the negative 3x squared plus 6x minus 4 equal to 0, you can solve that, but you'll get imaginary solutions. And that doesn't really help us here. Because if you get imaginary solutions, they're not going to be on our real grid. For the y-intercept, remember you set x equal to 0. In our case, right, setting x equal to 0, this makes, right, f of 0, makes this negative 3 times 0 squared, so that's going to be 0, plus 6 times 0 is going to be 0. Show yourself with negative 4, so you end up with y equals negative 4. I'll show it just so you see it. So it's y equals negative 3 times 0 squared plus 6 times 0 minus 4. So you end up with y equals negative 4. As an ordered pair, you would want to write this. All right, so I'm substituting it in here. All right, so negative 3 times 0 squared plus 6 times 0 minus 4 just gives us negative 4 because these all cancel to 0. As an ordered pair, this is 0, negative 4. So that we can plot on our graph right now. We know the y-intercept at 0, negative 4. So 0, negative 4, 1, 2, 3, negative 4 would be there. And you can also think about what would happen, you know, since we know our axis of symmetry here, if I'm 1 unit away this way, keeping it symmetric, we have to go 1 unit away on the other side of the axis of symmetry, so it puts me there. And if you wanted to, you could plot additional points by substituting the x values in and getting the y values out. I'm okay with you just leaving it as is. Since there were no x-intercepts, you know, we have fewer points than we did in the previous example, but we have an understanding of what this general shape is. Arrows on the ends, it does go on forever in both directions. And this is our function f of x equals negative 3x squared plus 6x minus 4. So hopefully that was helpful in learning how to graph parabolas. You know, you could have, for this x-intercept, set it equal to 0, solved using quadratic formula. If you don't know about that, the next video will cover how to use it.